So the question is that there are two tasks, task 1 and task 2. The principal benefits from the agent's effort in both tasks, UP equals x1 plus x2 minus w, where x1 equals to e1 and x2 equals to e2. The agent has payoff function UA equals w minus half in brackets e1 squared plus e2 squared minus e1 e2, where the incentive scheme is w equals alpha plus beta y, where y equals to x1, and the timing is as usual. Step 1, principal offers agent an incentive scheme, w equals to alpha plus beta y. And step 2, agent may accept or reject the offer. If he rejects, he receives an outside option of 0, that is u0 equals 0. Step 3, if agent accepts, then he chooses e1 and e2. Step 4, principal pays agent w equals to alpha plus beta y. So question A is, for step 3, given the principal's offer, w equals alpha plus beta y, write down the agent's maximization problem and calculate his payoff maximizing effort choices, e1 and e2 as a function of alpha and beta. So firstly, we just write down the agent's utility function, where UA equals to W minus half in brackets E1 squared plus E2 squared minus E1 E2. And we just substitute W with the incentive function into this utility function, which is UA equals to alpha plus beta y minus half in brackets E1 squared plus E2 squared minus E1 E2. And y equals to x1 equals to E1. So UA equals to alpha plus beta E1 minus half in brackets E1 squared plus E2 squared minus E1 E2. And what we want to find is the payoff maximizing effort choices. So to maximize the utility, we just take the first order of condition of utility regarding E1 equals to beta minus half in brackets 2E1 minus E2 equals to 0, and take the first order of condition of UA regarding E2 equals to minus half in brackets 2E2 minus E1 equals to 0. By combining these two functions, we can get the final result, which is E1 star equals to 4 beta over 3 and E2 star equals to 2 beta over 3. And question B is, for step 1, write down the principal's maximization problem and calculate his maximizing choice of incentive scheme. So firstly, we just find out beta. The principal will choose an incentive scheme that ensures that the agent gets exactly his outside option. So UA equals to U0 equals to 0. Then UP equals to UP plus 0 equals UP plus in brackets UA minus U0. Because UA equals to U0, so UA minus U0 equals to 0. So equals UP equals to, in brackets, UP plus UA minus U0 equals to U total. Here we just ignore the U0 because it equals to 0 equals, so UP equals to x1 plus x2 minus w plus w minus half in brackets E1 squared plus E2 squared minus E1 E2. Here we just cancel the which, because all the planner cares about is the effort level. An increase in W of $1 just means that the agent gets $1 more while the principal gets $1 less, which cancels out in the calculation of total value. So, and x1 equals to E1 and x2 equals to E2. So UP here equals to E1 plus E2 minus half in brackets E1 square plus E2 square minus E1 and E2. And from question A, we get E1 equals 4 beta over 3 and E2 equals to 2 beta over 3. We just substitute this result into this function and we get UP equals to 4 beta over 3 plus 2 beta over 3 minus half in brackets 16 beta square over 9 plus 4 beta square over 9 minus 8 beta square over 9. And about simplify this function, we get UP equals to 2 beta over 2 beta square minus 2 beta square over 3. And to find out the beta, we just take the first order condition of UP regarding beta, which is 2 minus 4 beta over 3 equals to 0. And from this function, we can get beta star equals to 1.5. So then we just find alpha. To find alpha, we start with UA equals to U0 equals to 0. So UA equals to W minus half in brackets E1 square plus E2 square minus E1 E2 equals to alpha plus beta E1 minus half in brackets E1 square plus E2 square minus E1 E2. And from question 1 and question B, we get E1 star equals 4 beta over 3 and E2 square equals to 2 beta over 3 and beta star equals to 1.5. We just substitute these results into this function, and finally we get UA equals to alpha plus 1.5 equals to U0 equals to 0. So from this equation, we get alpha star equals to minus 1.5.